Dear friends and colleagues, welcome to your channel, Thermal Engineering Concept and Principle. This is Professor Farad. In this episode, we will introduce some of the topics which are related to heat pumps. Here, we will go through certain issues related to heat pumps and how are heat pumps classified by their energy source and what is the economic feasibility of each type. Therefore, let us go through some details about this subject in the present episode. Dear friends and colleagues, welcome to your channel, Thermal Engineering Concepts and Principle. In this episode, I will introduce some ideas and information about the use of heat pumps. We have described heat pumps in more than 3 or 4 episodes, which have been published through this channel. In the present episode, we will go through the heat pump to describe the process of delivering energy from low source to space through the heating medium or the heating mode, and the opposite, where we can discharge energy to a low temperature source for the cooling process. We have heat pump where can be classified and to study the economic feasibility of each type of heat pumps. We have classified heat pumps according to the energy source, such as air or the energy of earth, where can be used for heating mode, or earth can be used as heat sink for the cooling mode. Thank you for your continuous support and encouragement to succeed in our mission by transferring knowledge to students, engineers, and specialists in this topic. Let us go through the objective of the present episode. The main objectives of the present episode, which focuses on heat pumps, is related to the classification of heat pumps according to their energy source. And then we will arrive to the closure of this part of the topic. In an air-to-air heat pump operating in heating mode, Thermal energy is transferred from outdoor air to indoor air using a vapor compression refrigeration cycle. First process occurs in the evaporator. The outdoor unit absorbs low-grade heat from ambient air as the refrigerant evaporates flow pressure and temperature. Second process occurs at the compressor. The compressor raises the refrigerant pressure and temperature significantly, approximately in isentropic compression. The third process occurs in the condenser. The indoor unit releases this heat to indoor as the refrigerant condenses at high pressure. The fourth process occurs through the expansion valve, where it reduces the refrigerant pressure, completing the cycle. Electrical work supplied to the compressor enables heat extraction from outdoor air and delivery to the indoor space, typically achieving a coefficient of performance greater than 1. In an air-to-water heat pump operating in heating mode, heat is extracted from outdoor air and transferred to water for space heating or domestic hot water using a vapor compression refrigeration cycle. The first process occurs at the outdoor evaporator, which absorbs low-grade heat from ambient air as the refrigerant evaporates at low pressure. The second process occurs at the compressor, which increases the refrigerant pressure and temperature. The third process occurs at the condenser, where the water-side condenser transfers heat to the circulating water, which could be radiators, underfloor heating, or storage tank, as the refrigerant condenses. The fourth and final process occurs in the expansion valve, which reduces the refrigerant pressure to repeat the cycle. Electrical work supplied to the compressor enables heat delivery to water at useful temperature, typically achieving a coefficient of performance (COP) between 2.5 and 4.5, depending on operating conditions. Here we have the direct contact geothermal heat pump, where earth is considered as a heat source. In heating mode, a geothermal heat pump with a direct contact, which is known as DX or direct expansion ground heat exchanger, operates as the following parts. First, heat absorption in a ground loop, which is considered as evaporator in ground. Liquid refrigerant, for example, R410A, is throttled to low pressure and circulated directly through buried copper tubing. Because its saturation temperature is below the ground temperature, typically between 10 to 18 degrees Celsius, it evaporates by absorbing sensible heat from the surrounding soil. And then this vapor passes through a compression process where it is compressed to a high pressure and temperature. Once it has compressed to these conditions, it passes through a third stage, which is called heat delivery indoors. Usually it is condenser in building. The hot high pressure vapor flows to the indoor heat exchanger, where it condenses and releases latent heat to the building air or a hydronic heating system. Finally, the liquid, as it leaves the condenser, passes through expansion and recirculation uh, process. The condensed liquid refrigerant passes through an expansion device, reducing its pressure and temperature before returning to the ground loop to repeat the cycle by following the blue side of piping. Dear friends and colleagues, this is the final part of this episode. That is the closure. We passed through the subject related to heat pump types according to their energy source. We focused on air and earth as heat sources for the heating mode. And we have to mention here that these two sources may be used for the cooling mode as well. We have some valuable resources which are presented in the form of a playlist with a link seated in the description box. You may pass through to find out more about energy and geothermal energy. If you feel that the content of the present video are useful to you and others, please subscribe to the channel and share it with your friends and colleagues to achieve the main goals from creation of this channel. I will see you in the next part to give some practical information about the economic feasibility of using the three types of heat pumps. Bye bye.